Chapter 4, Lesson 4, Problem Solving. Use tables to compare ratios. Our objective is that you will use the strategy Find a Pattern to compare ratios. Unlock the problem. A paint store makes rose pink paint by mixing 3 parts red paint to 8 parts white paint. A clerk mixes 4 parts red paint to 7 parts white paint. Did the clerk mix the paint correctly to make rose pink paint? Use tables of equivalent ratios to support your answer. Use the graphic organizer to help you solve the problem. First, we read the problem. What do I need to find? I need to find whether the ratio used by the clerk is equivalent to the ratio for rose pink paint. What information do I need to use? I need to use the rose pink paint ratio in the ratio used by the clerk. And how will I use the information? I will make tables of equivalent ratios to compare the ratios 3 to 8 and 4 to 7. Now we're going to solve the problem. So if we look at the parts red paint, it says 3, 6, 9, 12. That is going up 3 each time. If we look at the parts white paint, if our first ratio is 8 each time, that means we need to go up 8 each time. So 8 plus 8 is 16, plus 8 is 24, plus 8 is 32. So that's for the rose pink paint. Over here at the clerk's paint mixture, it says that he starts with a ratio of 4 to 7. That's our base ratio. So if we add 4, that gives us 8, plus 4 is 12, plus 4 is 16. And on the bottom we have 7, and we're going to add 7 each time, which gives us 14, 21, and 28. So think, the number 12 appears on top on both tables. Over here we have 12 to 32, which is not equivalent to what we have over here, which is 12 to 21. So the ratios have the same numerator, and I'm not going to scroll down, but right down here you're supposed to fill in where it says different denominators. Okay, so the ratio is the same. It's still 12 and 12, but because these denominators are different, they are not equivalent. So the clerk did not mix the paint correctly. Try another problem. In Amy's art class, the ratio of bushes to students is 6 to 4. In Tracy's art class, the ratio of brushes to students is 6 to 4. In Tracy's art class, the ratio of brushes to students is 9 to 6. Is the ratio of brushes to students in Amy's class equivalent to the ratio of brushes to students in Tracy's class? So again, for this one, we're going to fill out this table. And maybe okay, so what do I need to find? I need to find whether the ratio of brushes to students in Amy's class is equivalent to the ratio in Tracy's class. So again, what do I need to find? I need to find whether the ratio of brushes to students in Amy's class is equivalent to the ratio in Tracy's class. What information do I need to use? So I need to use the ratio of brushes to students in each class. Which is 6 to 4 and 9 to 6. How will I use the information? I will make tables of equivalent ratios. To compare the ratios six to 4 and 9 to 6. So solve the problem. So down here we're going to make that table. So this is going to be for Amy. And this is brushes and students. And we're going to do 6 to 4. And then over here for Tracy, I'll draw another box. And they are brushes to students, and the ratio is going to be 9 to 6. So if I'm going to add 6 each time, that will give me 12 plus 6 is 18. 18 plus 6 is 24. If I start with 4 on the bottom, I'm going to go up by 4 each time. So 4, 8, 12, 16. Tracy's I start at 9, so I'm going to add 9 every time. So it's going to be 18, 27, 36. And students, I'm going to add 6 every time, which is going to be 12, 18, and 24. So now I got to look and see if there's anything in common. Well, I see 18 in the numerator in both tables. So I'm going to look, and I have 18 to 12 here, which is equivalent to 1812, which I have here, 18 to 12, which means that the ratios in the first table are equivalent to the ratios in the second table. So the ratio of brushes to students in Amy's class is equivalent to the ratio of brushes to students in Tracy's class. Use patterns. Explain how you used a pattern to determine whether the ratios in the two tables are equivalent. So I saw that both tables include the ratio (18 to 12). Since the same ratio appears in both tables, the first table must be equivalent to the ratios in the second table. So again, I saw that both tables included the ratio 8 to 12. Since the same ratio appears in both tables, the first and second table must contain equivalent ratios. So number 2 says, tell how writing the ratios in simplest form can help you justify your answer. When you write the simplest forms, so when you simplify the ratios in the first table, you find that they are equivalent. Well, when you simplify ratios in either table. So we have 6 to 4, which if you divide both those by 2, you get 3 to 2. And then the second one is 9 to 6. Divide both of those by 3, you get 3 to 2. So if you put those both in simplest form, you could already tell that they were equivalent. If you have any questions, please ask your teacher. Just a reminder what our objective was today, and that is that you will use the strategy find a pattern to compare ratios.